Hi everybody, good morning. Today we're going to do a topic that is basically related, but it's kind of confusing at the same time. Um, I know there's so many drawings out there. I'm actually going to look at diffusion and osmosis. I'm pretty sure that everybody has heard about this.
No.
Anybody? No?
No idea.
Good. By the end of the lesson, we will know. Want to tell me anything about diffusion or osmosis?
One is kind of if you use like cell membrane, like the material inside the cells and the outside cells, they can transfer by the little pore on the membranes.
Right.
So that's diffusion. And osmosis is like the air, the smell. Like when somebody cook there and you can smell here, so that's osmosis.
You're right, your examples are right, but it's the other way around.
Oh really?
Yeah.
Oh my God.
It's the other way around. No, but they're good though. So like she said, if somebody's cooking a really good meal, and let's say we have a kitchen right there, and you are walking in, you feel the smell like right by outside. So the whole process of you feeling, that smell or something like that is diffusion. And for the cell membrane, we're gonna get there on that later, is osmosis. Let's just get on it. So here I have like 3 illustrations basically to help us understand this. So I have a container full of water, and let's take this to be a color, like let's say red. If I took a container that has water in it and I dropped like a drop of red color, or let's say sugar molecules, right? Over time, what is going to happen?
The whole water in the container will become red.
Exactly.
Gradually.
Right.
Right.
So eventually, this whole container is going to be red, right? Because we have all these molecules having like all these random movements, and eventually, like she said, we're going to have the whole container being red. So basically, if I drop this my red color at this little corner right here, like she said, eventually the whole thing is going to be red. But if we look at only this one corner, we have many molecules of this color than we do on this other side, right? So which means at this little part of the container, the concentration of the color is higher than on the other part. So that's where the diffusion comes in, which means basically to define diffusion is the movement of molecules, and it does not matter what molecules it is the movement of molecules from a high concentration to a low concentration area, just like that. So basically another example would be if I came with a perfume or cologne and sprayed on that corner, at the end of the day, the whole room will smell like cologne, right? So for this illustration right here, is going to help us. I'm sorry, just one more thing. So let's say if this was sugar molecules, the thing that dissolves in something is what we call a solute, right? Is a solute. And then under conventional methods, we like to use water as a universal solvent. So water molecules, since it's the thing that dissolves the solute, it's going to be called
Solutant.
oh God.
Solutant.
Solvent. Yeah. And the combination of these two is what we call solution.
Solution.
Just like you can make tea. Tea is solution. So this illustration is going to help us to define the different kinds of solutions that we have. Let's take 2 containers that have this little connection right here. So random movement of molecules, water and other molecules here. Let's say we have like 3 molecules, right? And then 1 molecule moves to this side. Just random, we didn't say. I mean, at the end of the day, we are going to have basically an equal, movement of molecules that are going to balance. But let's say we have 1 molecule here and this molecule right here, right? This solution at this part is highly concentrated than the other side, right? So is what we call an hypertonic solution. Hyper, you know,
Water?
huh?
Liquid?
Hyper is something that is hot, right? I've got the medical, and then you hear somebody say you're hyperglycemic. You have too much sugar in your body, you know. So the opposite of hyper is what? Hypo. So this one here is going to be hypotonic, which means it's less of it, right? So, any questions on the solutions? Okay. So let's get down to osmosis. So I take, like she said, let me get an example. Let me use an example of what she said. A cell membrane. You know, take any cell in the body. Now, the cell membrane, if you, let's say you magnify it, it's going to look like this, right? There's these little pores right here. And then there are movement of substance that happen in between the cell and outside of the cell.
Yeah.
Now, in the body, proteins are large molecules, right? They can't go through the cell membrane, right? So you have these big molecules right here that cannot, you know, go on to this side right here. So they will just remain on one part. But on the other side, you have little molecules. I'm going to use water. They can move either way, right? They can move to the other side or to the other side.
Mm-hmm.
So this membrane here is what we call semi-permeable. Permeable means allowing, permeable means allowing movement of stuff, right? So semi-permeable means it only allows a set of molecules to move in and out. So in osmosis is basically where we have movement of, most of the time is water molecules from a high concentration to a low concentration area. Just the same thing, you know, like osmosis. But now the only thing that you have to add to that definition is through a semi-permeable membrane. That's basically the only thing that you have. They, like I said, they are related processes. You just have a very slight difference between them. And like cell membranes, at the end of the day, if you have a lot of water molecules moving in, most of the stuff that happens, and this you don't pray that this does not happen in your body, is that this membrane is going to swell, right? It gets to a point where it's, you know, maximum. It can't take it, just like a balloon.
Mm-hmm.
If it goes past that capacity, it's going to burst.
Uh-huh.
You do not want to have busting cells in your body. Long time.
Is there a possibility that it will really collapse or bulb?
To burst in your body? There are possibilities.
Oh,
but, you know, metabolism in the body, or basically body processes, have control over that. There's a way the body that prevents that from happening, because that would be a disaster.
Yeah.
You know, that would be a disaster, because our bodies are made of like 85% of water. So you know, that water, there's a way it's being used in the body that, you know, it does not make those cells swell until they burst.
Okay.
Any other questions? Thank you.